Next definition, orthogonal matrix. A square matrix capital A is said to be orthogonal matrix if A into A transpose equals to A transpose into A equals to I. I is nothing but identity matrix. Idempotent matrix. A square matrix is said to be idempotent matrix if A square equal to I. Next, another definition, involutory matrix. A square matrix is said to be involutory matrix if A square equal to I. Next, unitary matrix. A square matrix capital A is said to be unitary matrix if A into A power theta equals to A power theta into A equals to I. Here A power theta equals to A bar whole transpose or A transpose whole bar, both are same. Problem, show that capital A equal to I 0 0, second row 0 0 I, third row 0 I 0 is a skew Hermitian matrix, and also show that unitary matrix. Given matrix A equals to I 0 0, second row 0 0 I, third row 0 I 0. To prove skew Hermitian matrix, A bar whole transpose equals to minus A, you have to show that. If it is A bar whole transpose is minus A, then A is called directly skew Hermitian matrix. For that purpose, A bar whole transpose is denoted by A power theta. Separately I am calculating A bar. First of all, A bar is nothing but conjugate of A. Conjugate of A is conjugation of each and every element of the given matrix. Conjugation of I is minus I. Now conjugation of 0 is 0. I am writing directly 0 0 0. Now second row third column element, that is I. Again conjugation of I is minus I. In the third row first element is 0. Directly I am writing 0. Conjugation of 0 is 0. Conjugation of I is minus I. Again last element is 0, conjugation of 0 is 0. Once again A bar equal to minus I 0 0 0 0 minus I 0 minus I 0. Now conjugation is over. Now you should transpose the above matrix, means interchange the rows and columns, that is A power theta. A power theta equal to A bar whole transpose. When you are interchanging rows and columns, the resultant matrix will be minus I 0 0 0 0 minus I 0 minus I 0, that equals to minus I am taking common I 0 0 0 0 I 0 I 0. Now minus this matrix is nothing but minus A. Therefore, A power theta equal to minus A. A is skew Hermitian matrix. For unitary matrix, you have to show that A into A power theta equals to I. Now I am taking A into A power theta. A is I 0 0, second row 0 0 I, third row 0 I 0 into minus I 0 0, second row 0 0 minus I 0 minus I 0. Now you have to multiply these two matrices. Once again matrix multiplication rule, columns of the first matrix equal to rows of the second matrix, that is the rule of matrix multiplication. It has satisfied that property. Now in this matrix multiplication, first row first column, you have to multiply first row first column. I into I is I square, that is minus 1. Before that we have minus symbol is there, that becomes 1. 0 into 0 0 plus 0 into 0 0. I am writing like that. You have to multiply first row first column, first row second column, first row third column. Next in the same way, second row first column, second row second column, second row third column, and third row first column, third row second column, third row third column. When you are doing like that, we are getting directly 1 0 0 0 1 0 0 0 1, which is I. Therefore A into A power theta equals to I. A is unitary matrix. After completion of the definition of rank definition, I have taken one problem here. Find the rank of the matrix A equal to first row 1 2 3 4, In the first row we have 4 elements. Second row 5, 6, 7, 8. Third row 8, 7, 0, 5. Given matrix A equal to 1, 2, 3 and 4. Second row 5, 6, 7, 8. Last row 8, 7, 0, 5. Order of this matrix I am writing here 3 by 4. Now already I told you that in the definition, rank of A is less than or equal to minimum of m comma n. Here m is nothing but number of rows and n is nothing but number of columns. Now according to that definition, rank of A is less than or equal to minimum of 3 comma 4. This implies rank of A is less than or equal to 3. Rank may be 3 or 2 or 1. Directly means you have to consider any 3 by 3 submatrix. Now submatrix is nothing but delete any row or column of the given matrix, then the resultant matrix is nothing but submatrix. Then I will delete the fourth column. After a deletion of fourth column, I am writing here determinant of 3 by 3 matrix 1, 2, 3, 5, 6, 7, 8, 7, 0. Now expand the determinant along the third row, because third row contains 0. Then if you are expanding the along the third row, then it will be easy. 8 into, delete the first column and third row, the remaining 2 into 7 is 14, 14 minus 6 into 3, 18, 8 into 14 minus 18 minus 7 into, again second column you delete second column and third row, the remaining determinant 1 into 7, 7 minus 5 into 3 minus 15, anyhow 0 is there, 0 into something 0. 8 into minus 4 minus 7 into minus 8 equals to minus 32 plus 56, 24, which is not equal to 0. If the determinant of 3 by 3 is not equal to 0 means rank of A equal to 3. Like this we can calculate the rank of the matrix.